I recommend using negative 2, negative 1, 0, 1, and 2, just because we know it's going to be centered around where x is 0, right? Okay, so that way we'll have 1 point in the middle and we'll have two mirrored points on either side, right? So it gives us the nice prediction of what the shape of it should look like. So that's why I use those. Really, I could use anything as long as I use the middle point and 2 points on either side of it. But negative 2, negative 1, 0, 1, and 2 is a good one. And I wanted you guys to use those so that way your t-tables would look just like mine if you did them correctly. So that's the main reason I wanted you to do it using those exact points. But technically you could use, negative 472 and positive 472 if you wanted to. You'd have to make a really, really ridiculously big graph, but, you could do it. So if I'm going to graph this, I first need to plug into my t-table. A lot of people, I think, are still having issues with just following basic order of operations rules. Guys, this is the whole reason we did a Unit 0 at the beginning of this year, is to refresh on those basics, okay? And then you refreshed on them and did really well on the test and then went, okay, well, we're done with that. Now I'll just do it in whatever order I want. No. You still have to follow order of operations. So when we're plugging into a t-table, all I'm going to do is I'm going to take my equation, in this case y equals negative x squared plus 2. And we're going to do y equals, now the first x value I'm going to use is negative 2. Now one thing that some people I know had a problem with here is they wanted to make it negative 2 and make it positive 2 squared. There's a slight difference here in the fact that this is not negative x squared. When we first started talking about exponents, we talked about that there's a difference between negative 1 squared or negative 1 squared. The difference is this one, negative 1 squared, is 1 squared and the negative of whatever that is. Because the 1 is attached out in front. In other words, the only thing that's being squared is what? Just 1. Here, since I have the parentheses, that means I am multiplying negative 1 times itself. Here I'm multiplying positive 1 times itself and then attaching the negative to the answer, which means this would be negative 1, because 1 squared is 1, so the negative of that is negative 1. Whereas this one, negative 1 squared is negative 1 times negative 1, which is positive 1. Okay? So, another way you can do it for this case is if you think about it, negative x squared is the same thing as negative 1x squared, right? Negative 1 times x squared. So you could write it that way. Negative 1 times, now x squared, x is negative 2 in our first one, right? I see a lot of people like staring off into space. I know it's early in the morning, but guys, we've got to be focused on this. Alright, so negative 1 times negative 2 squared plus 2. So, order of operations says what happens first?
Parentheses.
Okay, well parentheses, do they have an operation inside of the parentheses?
No.
What operation is going on inside the parentheses? Well, the squared is not inside parentheses. The parentheses there are just to show you that it's negative 2 squared, not negative 2 squared. Okay? So, the parentheses aren't an order of operations thing. They're a, hey, you need to know that it's negative 2 times negative 2, not 2 times 2, and then it's just the negative. So, we don't need to do parentheses here. What we do need to do first is exponents. Okay? So, Megan, what is negative 2 squared? 4. So, I have negative 1 times 4 plus 2. And the next thing I have to do is multiplication. Negative 1 times 4 is negative 4. And then negative 4 plus 2 is negative 2. So that gives us our first entry in our t-table. I'm just going to do this to save time. Alright, so this is negative 2. That also means that that one down there is going to be negative 2. Because if I plug in the same thing and I do negative 1 times 2 squared, well 2 squared is 4, and that times negative 1 is still negative 4, plus 2 is still negative 2. Remember, that's the whole point of this, is that those mirrored, they're going to be mirror images. So whatever you get for your value for negative 2, you will get for your value for positive 2. Please remember though, this is only true if your quadratic equation is missing what? Yes. Okay. I'm telling you this because I know it. I can see it coming. Next year you're going to be in Miss Slay's math class or Mr. Carn's math class, and they're going to have an equation that looks like, 4x squared minus 2x plus 3. And you're going to say, oh, but it's supposed to be centered at 0. Miss Nichols told us it's always centered at 0. No, it's not. It's only centered at 0 if that thing doesn't exist. Okay, if you have an x squared and a number, then it's centered around 0. Okay, if it has another x term in there, that's going to change where it's centered. It can be moved to the left or shifted to the right, depending on what's being added or subtracted. So, do not tell your teachers next year that Miss Nichols told you that it would always be centered around 0. That's not true. But the ones that we're working with this year will always be centered around 0. Okay? So, since ours are always centered around 0, that's why I know negative 2 and positive 2 are going to give me the same y value, right? Negative 1. If I plug in negative 1 here, this is my equation. Negative 1 times negative 1 squared plus 2. So again, I have to do exponents first. Negative 1 squared is 1. That times negative 1 is negative 1, and negative 1 plus 2 is positive 1, right? So this value should be positive 1, which means this value will also be positive 1. And then 0 is the easiest one because remember, the 0, it's just like the y-intercept in a linear equation. It makes all the x terms go away, so just your constant is going to be your y-intercept there. So those are our points. And then we need to graph them. Now this one's very convenient to graph counting by ones because none of our numbers are bigger than 5, so they'll all fit. So 0, 2 means I go up to 2. Negative 1, 1 means I go left 1 and up 1. Positive 1, 1 goes right 1 and up 1. And then negative 2 puts my point here. And positive 2, negative 2 puts my point there. Alright, so those are my points. One thing someone in my 8th period asked yesterday is they said, well, don't you always make straight lines between points? No, that's only if it's linear. This isn't linear. You're going to sketch what this looks like, but you know linear, that a quadratic is going to be like a curved U. So all you're going to do is draw a curve. Oops, that wasn't very good. That was still not very good, but all right. There, that's a little better. All right. So you're going to draw a curve as best you can that connects those points, but curves through them. Now, one thing you notice, if you look at the answers I gave you, two of the answers on your homework were opening downward. What do you see in common about those two? Negative x squared, okay? It can be negative 1x squared, it can be negative 3x squared. But think about it, if you have x squared, it's going to be, what happens if you have x squared? It's going to change the sign to a positive, right? So the only way that it's going to open downward, the only way it's going to have negative values is if you then take that positive number, whatever x squared is, and multiply it by something negative. Okay? So that's what's happening here. This, when I squared it, I automatically get a positive number, and then I turn around and multiply it by a negative number, so I automatically get a negative number. Okay, so if your x squared term has a negative coefficient on it, then you know that your parabola should be opening downwards instead of opening upwards. So that's a little trick too to make sure that you're doing it correctly. You need to know negative exponent on your x squared term means opening downward, positive means it's going to be opening upwards. All right, let's look at number 3. So and now I saw some people who did their table like the table on the front. If you want to do a table and show your work where you plugged in and, you know, because I can do order of operations in my head really easily, but I've also been doing this math for a long time more than you. So if you need to write it out, then write it out. I promise I will never deduct points for you showing too much work. Okay? You're always good to show extra work. So if you need to show that, now I'm fine with you doing the XY table and then just plugging in your head and getting the answer. But if you're doing that and you're not getting the right answers, then you may want to take the time to actually show how you're plugging in and make sure you're doing your order of operations correctly and things like that. So this one here, again, I'm going to use -2, -1, 0, 1, and 2. So if I plug into this, my first one is y equals -2 squared minus 2, right? Everyone see where I got that from? Just plugging into an equation. We took our first x value, replaced x with it. So y equals -2 squared, which is 4, minus 2 is 2. So this is 2, and this one will also be 2. All right, -1. If I plug that in, -1 squared is +1, minus 2 is -1. So this is -1, and that one's -1. And then the last one we have is 0. Which again, the 0 is easy because it just makes that term go away, so I'm left with -2, right? So doing that on a graph, we have 0, -2, so that's down here. Is this one going to open upwards or downwards? Right, it's going to open up because look at my x squared. Is it a positive x squared term or a negative?
Positive.
Positive, right? So that means it's going to open up. Okay, then we have -1, -1, and we have +1, -1, and we have -2, 2, and +2, 2. So those are our points, and then again we just kind of roughly connect them. So it looks something like that. Alright. Do you guys want me to do any of the other ones, or you think you're getting the concept now?
Four.
You don't have to know.
Yes.
What? No.
Yes. 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 Yes.
Oh. Alright. Okay, guys, for this one, same exact thing. Again, I'm going to pick -2, -1, 0, 1, and 2. Plugging in, if I replace x with -2, so I get 3 times -2 squared minus 1. What gets done first? The exponents has to get done first. So -2 squared is +4. Then what comes next? Multiplying. So 3 times 4 is 12, and minus 1 is 11. So this is 11, and that one's 11.
I didn't know how to do that one because I didn't do the exponents first, so I did 3 times -2, which is -6, and I did 6. We did a power of 2, 36.
Order of operations. You got to remember those. They're kind of important. Big deal. All right. So, if I do -1, then I get -1 squared, which is 1 times 3, which is 3, and 3 minus 1 gives us 2. So that's 2, and that's 2. And then, of course, the last one is easy because that just makes that go away. If x is 0, then y is -1. Now, when it comes to graphing this, we know it's going to open which way? Upward, right? It's positive. But we also have this value and this value, which are way bigger than the 5 units we have included on our graph. Now, you can count by 3s to include it on there, or I was like, you know what? 10 is on the graph if I count by 2s, and 11 is just barely above it. So I just kind of cheated a little and then counted by 2s and then just put my 11s just like half a step above the graph. So you can do that also, or you could count by 3s, either way. Now, one thing you need to be clear on. I can count by 3s or 2s on y and still count by 1s on x. Your x and y do not have to be labeled the same way. So just because like if I counted these by 3s, then these points would not, my graph would be all in between these lines, right? It wouldn't even make it out here. So you don't have to count by 3s on y just because you count by, or on x just because you count. So what I did is I made this 1, 2, 3, 4, -1, -2, -3. But I made this 2, 4, 6, 8, 10, like that. Okay, so that's up to you. It's your option. Just make sure if it's on a quiz or a test that you label what you're counting by. So if I do that, then 0, -1, I'm going to go down half of 1 because I counted by 2s. So that puts it right there. And then -1, 2, I'm going to go to the left 1 and up just 1. Because remember, going up 1 is counting for 2 on y. And then the mirror image of that, +1 up 2. And then I have -2 up 11, so that's, like I said, about half a step above the top. And then +2, 11. And then all I have to do is roughly connect. And there we go. All right. So I want you to get some more practice with this tonight. Oh, yeah.
Are you sure you want us to?
I'm sure. I'm quite certain. So let's see which ones I want you to do. Let's do the 9/8 skills practice for homework tonight. Alright guys, you do have a little bit of time to get started on it, and that way if you do have questions and want some individual help, I can come around. Yeah, now that you know your grade, now that you
Can I go get my workbook? Can I get my workbook?
yeah. Yeah. Your workbook? It is, but I had to leave last year. I didn't use it much last year.